Recursion. It is nothing but a function calling itself. So I should ask you a question. Is this enough to solve any recursion problem? No, it's not exactly like this, because you need to know more things about recursion to solve any recursion problem that you may see, right? So hey guys, welcome to my video. Today we'll be breaking down recursion in basic two categories, where we'll be learning that how a problem if comes in front of me that is to be solved by recursion, how, what my mind should think, what thought should be striked in my mind so that I can implement recursion in that question, right? So first of all, let me tell you that if a problem is in front of you and you get an idea and you figure out this thing in your brain, that this problem will only be solved by if I explore every single path that is possible in that problem. If I explore every path and I need to find best in that path, if I need to calculate the maximum among that path, then only the recursion comes into picture, right? So if you have figured out this thing, this video is for you, because I'll be telling further two categories after thinking that this problem will be solved by exploring the paths, what you need to do. So I'll be telling two approaches in this video. That would be take and non-take approach, and the second one would be I will use a loop for calling function. This would be the second type of question that comes under recursion. So the most standard question, that is longest common subsequences, are solved by take and non-take approaches, and all the DP grid problems or grid problems are solved by function calling in a loop, inside a loop, if I call a function when it is under loop, right? So let's discuss both the scenarios by one example each, right? So I have written a question in front of you where I have been given a array of length 5 and I have been given a sum integer, that is 8. Right now it's given to us, and the question is asking that is there any subsequence exist in this array which is of length 3 and which sums up equals to 8. If it exists, I need to return a boolean, whether true or not, right, or false, sorry. So let's get into this problem deeper and let's try to understand what it is asking for and how can I solve it, right? So I have written the array over here, right? Let me erase this. Another thing I should do is I should index it. So I am indexing 1 0 1 2 3 and 4, right? So this is in front of you, right? So suppose I'll go to every index, and what I'll be doing is at every index I will have two choices with me. I'll ask myself at every index, suppose I'm on index 0 right now, and I'll ask myself whether I should take 3 or I should not take 3. I'll ask myself only. If myself is answering that you should take 3, then I would be subtracting 3 from sum. I would be subtracting 3 from sum because I've taken it, right? Now another option with me is to not take it and move ahead. First option was to take it and move ahead. Second option is to not take it and move ahead. If I'm not taking it, then I won't subtract it from my sum. If I'm taking it, then I will subtract it from my sum. So at every single step, I will always come up with two choices. That is always be take that index or not to take that index. So this approach is simple, where you have only two possibilities that you can have. First one is to take that or to not to take that. So when I'll be with this I'll be exploring every single path that is possible in this array, and at last I'll be figuring out that I can get index 0, index 1 and index 3 to be included in my answer, since they are of, if I write this, yeah, so since they are of length 3, and if we'll be summing up it, it would be 8, which was the required sum. So if I have received it, I need to return true. If I would have not received it, then I would have returned false, right? So this is the basic first approach, in which what I'm doing, I'm asking myself, I'm asking at every index whether to take it, whether to not, right? This is a simple approach that can be used in many questions. I'll be telling you questions as well in which this kind of approach is used in later videos. So let's move to the second approach, or the second category that I have with me. What second category is doing? This category is used in those problems in which at every step I don't have one choice, I don't have two choices, I have multiple choices. Suppose I have been given an array. Suppose this is a 2D matrix or 2D array. See, this is -1 over here, and -1 depicts that it doesn't have any path, right? So this is the basic array, you can see, right? This is row 1, this is row 2, this is row 3, this is row 4. Fine. So at every step in this, I will have multiple options with me. What are those multiple options? Let's see. Multiple options are, first of all, what is to be give output in this question. So the output of this question would be, you need to return a minimum path sum that is possible. So see, you need to return minimum path sum. That means you need to think about recursion, because while getting minimum path sum, you need to explore every single path, and if you have explored every single path, then only you will be able to figure out that which is the minimum path, right? So you need to think like this. If you have figured out this thing, damn, you need to go ahead. Now suppose if I'm standing over here, let me use this color. If I'm standing over here, I have 4 options with me in row 1. I have 4 options with me. That is, I can go with column 1, I can go with column 2, I can go with column 3, I can go with column 4. I have 4 options with me. So this simply tells you that this won't not take or take approach won't work over here, because I have not 2 options, I have 4 options with me, and I need to explore every single path. So how I'll be exploring? Suppose I am starting with row 1, column 1, then the path may be this, the path may be this as well, the path may be this as well, the path may be this as well. So there are many possibilities at every column, and I have 4 columns, so many possibilities would be there. So I'll be exploring all those possibilities, and after exploring every single possibility, what I'll do is I'll figure out the minimum among them, right? So how this approach is different from the previous approach? It is simple. Previous approach were having at every index, previous approach just having 2 choice. It has just two choice, that is to take it, to not to take. And in this we have multiple choices. We can go by column 1, we can go by column 2, we can go by column 3, we can go by column 4. So these are the problems that can be, in which you can see this thing, that only taking and not taking wouldn't work over here. If you can think this thing, then you can think the second approach, that is, should I go with the second approach in which I have multiple choice with me, and if it works, then you can implement it. So simple है. रिकर्शन आप इन 2 चीज़ों की मदद से सॉल्व कर सकते हो, एंड आई कैन अश्योर यू, आई कैन गारंटी इट यू that if you master these things, both the things, if you do even 2 questions of both, you will be able to solve around 70% of recursion problem out there. Because if you want to solve higher concepts, that is DP, that is tree, if you need to answer them, if you need to solve those, you should be good in recursion. And recursion has only this mantra: you should know these 2 approaches. If you know this, you'll be killing recursion, right? You need to just practice then, because you are done with the concepts. You can just dry run your question and try at least 3 4 questions. 4 questions if you have tried of both, then you can move ahead in recursion or higher concepts. So this is all for this video. If you really like this kind of content, because recently I've started my channel, if you really like this, please subscribe to the channel, please like my channel, so that I can get more and more motivation to make such kind of videos that are useful for you.